today we are going to start, I would say, softer sides of the discussions in this particular course. Uh, Typically, this is divided into three equally demanding kind of parts, and we have already navigated with two of them. So the rest of the course is more focused towards the cost estimations and general things more that you will see on the construction sites. So this is where we will be extremely focused on construction specific things. Earlier, all our examples were quite generic and all those principles are very generic. Now onwards, we'll go into more construction relevant examples, and some of these principles that I'm going to talk about may not be even relevant for other industry. So it's mostly for construction industry. So, but some of them are definitely even extendable to other projects and other type of industries. So you will have to make sense if you are a non-civil engineering student. Otherwise, you'll be able to follow easy, right? So, again, the main context that we are starting with is, in general, so far the problems that you have addressed or solved in this class, they all had the cost and the cash flow series given to you, more or less. But in real world, you have to estimate, and that's what you are also doing in your projects sometimes. Yes, one method is to borrow the information from somewhere else, so with suitable assumptions, but a lot of time you need to do a more micro level estimating and built up from scratch, where you may not even have any other information directly applicable from a previous previous project of similar nature and all. Because no matter what you do, every civil engineering project has uniqueness in terms of no one metro railway is same as the other metro railway. For example, the number of curves in a metro railway would be different, even if the length is 10 kilometers in Delhi versus 10 kilometers in Bangalore or 10 kilometers in Chennai, right? Or the underground content versus the overhead content might be different. And these components can have, on an average, you can transfer some of these values, but sometimes you can't, right? For example, if you have to do underground construction in Chennai, the soil conditions are very different compared to what you have in Delhi, for example. So the costing that you directly take from Delhi may not be relevant for you. So the idea is that you can actually start building all these cost numbers directly from scratch, right? So as a construction project, how do you do that? Again, BTech students in civil engineering will also, I think you are already doing this to a certain extent in terms of your CPM course, but we will also cover this in the particular segment. Okay, so one thing that you need to realize is there is no easy way to estimate costs. This is a cumbersome process and it involves inputs from multiple people across the organization. There will be no one single person who will be able to tell that this is the total cost for this particular project. You have to really gather information from a range of different players, offices, and so on. So typically you will see, I think even in the organizational structure wise, at least in Indian companies, your finance department really seriously takes their monitoring activities like really seriously, right? Because they want to get a latest information of the real-time estimate, almost to the real-time estimation of what is happening, what is cost. Because a lot of people ask them this information whenever they have to plan for the next. So finance department is really important. Their job is not to pay you salaries and things like that. Their job is to maintain the repository of what is happening, what is the material price, or how much quantity they have estimated before, a really large repository, and then able to help you estimate, right? I'll just give you some ideas on what kind of information you may need to calculate the typical costs that are involved in a construction project, right? So the first and foremost thing is, it starts with a construction schedule. So for those you don't know, typically, suppose you have 10 activities to finish in a construction project. That could start with foundation all the way to laying up the foundation or digging up the ground, then laying the foundation, starting to construct the pillars, maybe had the bricklayers, then do the roofing, things like that. Then finally you do some sort of a tiling to make it look good, painting and all. Each of these are activities, right? And not all of those activities will happen in a single or simultaneously. There is a sequence of activities that's something needs to be done before something else has to start. For example, pillars cannot be erected before you actually finish the foundation work, right? So because of that, what happens is you have some sort of a diagrams in terms of how different activities are distributed over time, right? And this is very essential information, because once you know the activity, then corresponding to quantity of that activity, you can estimate how, in order to do this much of activity in this much time, how many resources you will require and at what time, right? Resources could be materials, resources could be labors, resources could be equipment, machinery, whatever. But essentially, this is a fundamental backbone for calculating that. The time related information on when each event is happening is given in the construction schedule. How to prepare construction schedule is not the scope of the current class. In this case, you are given the construction schedule. There is a whole science and engineering around that, which we cover in a different class. But idea is, once you know the construction schedule, you know the time at which an activity will start and the time which at an activity will likely finish. And once you know an activity, you know the cost that it will take in terms of borrowing all the resources required to do that activity. And therefore, you also know how many resources in what quantity you will need at what time, right? And this information you can use to create the cash flow, right? Essentially, cash flow is what? The other side of cash flow, this is only cost. Other side of the cash flow is your payment. How much your client is paying to you, at what intervals, how much money, that's a different formula. But essentially, the cost side of the cash flow, you can estimate using this fundamental principle. Clear? Okay. So, essentially, you split the projected quantities into a bar chart form. Bar chart essentially tells you in monthly wise how much of what each activity is going to happen. That's the bar chart. Calculate the cash inflow and outflow schedule based on the contract condition and contractor's payment agreement with labor, vendors and suppliers. So, costing is as a contractor, you are bearing the cost and you are constructing, and that is occurring to you as and when you construct. But payment is dependent upon many other things. Payment is dependent upon how frequently client is going to pay to you, right? To a certain extent, costing is also dependent on other factors. For example, you might have a relationship with your subcontractors or your suppliers that I will pay you monthly. I will not pay you if I'm buying 2 bags of cement today. I'm not going to pay you 2 bags of cement today. In a month, on an average, whatever I'll pay at the end of the month, I'll come and settle your account, right? Typically, this industry works like this. So you keep on getting the material, and then monthly or a predefined period, you release the payment. So you could have that relationship with your subcontractor, which will of course affect the timing to a certain extent, as well as you could be dependent on client to get money similarly. Client also has its own ways. Some contracts specify that you will get money only after the end or the project has been completed. Some projects specify that it is every month you will get, or every bi-weekly you will get. There will be this process, you need to submit the bill and blah, 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 right? So all those actions will affect your timing at which cash flows occur. But fundamental remains same. Ultimately it is primarily governed by the schedule or the bar diagram about when is what activity is happening. Okay, understood? All right. So essentially using this, you can generate a cash inflow and outflow. For now, cash inflow we will deal later. Outflow, there can be cost of many types. The simplest classification is something called a direct cost and a indirect cost, right? So direct cost is typically your labor, which is your human resources required to do a particular activity. For example, if you want to erect a wall, you need 2 masons, you need 3 people to transport the brick from site 1 location to where actually the brick erection work is happening and things like that. You also need machinery and plants. Plant is essentially your, for example, RMC, ready mix concrete activity. So you need to have that into account of this. Or machinery is tower crane, how much tower crane uses in a particular month and all. That is a direct resource required to do the particular activity. You also need to know subcontractor schedule. Of course, there is also material information. I'm not giving you exhausting, just give you an idea. Essentially, direct costs are cost which you can directly or easily attribute to a specific activity. You can tell that this many masons are required for this much of wall activity, right? You can directly bill them. So, this is a one-to-one mapping, and therefore, these are called direct cost. But then there are indirect cost. These costs are costs which you cannot pinpoint that all of these costs are happening to a single activity or a specific activity. These are collectively being accrued and you need to have them. Without them, you can't function, but then you cannot really attribute them to a specific activity. For example, maintaining the storage. In a site, store maintenance requires money, right? You need to keep it in a good condition, maybe air conditioned to keep the temperature in a certain limit or blah, blah. But then storage can be used for so many things. You can store your rebars there, you can store your cement bags there, you can store your maybe a specialized type of sand there or paint material or any admixture that you need to add to the cement and all. And not all of them will be required at the same activity. So, storage cost is something which is distributed across different type of activity depending upon the materials requirement, right? There could be storage for machinery. Now, you cannot argue that this particular what we call, in Hindi we call it tagari, I don't know what exactly you call in English. Essentially, on small construction sites you will find where people are having this hand tool to transport the material keeping on their head, right? Now, you cannot argue that this one is only occupying like 0.1 meter square in my storage area. So, that 0.1 meter square I will attribute to this particular. You can't do that typically. So, you're like, okay, on an average 100 this machines, 100 this machines are input in my store activity. All of them will be distributed through some extent equally to the site and things like that, right? So, that is your indirect cost which you cannot attribute to a specific activity directly. And then there are other type of costs, like we also saw before that there are fixed costs, variable costs, that kind of distinction. But here, most of what is important for you is to know direct versus indirect distinction. There could be also, for example, headquarters cost. Now, when we are just changing the scale of the discussion that we are having, while it is difficult for you to attribute some specific element to specific activity, it is also impossible for headquarters to attribute specific activity to a specific project, right? And in that 0.1 man hours for a headquarter design person was useful for this activity on construction site. It's impossible to do that analysis and it's often useless to do such kind of a detailed analysis. Therefore, you club them as a whole and you put them on indirect cost, right? Yeah, sometimes it also is dependent upon what you define as direct versus indirect or how rigorous you want to do this exercise. Also depends upon the relative volume of that. For example, simple things if you take and your direct costs are somewhere about 80-90% already of indirect cost, then it's okay. You can accept that because there's you not knowing information on where the indirect cost is going, it's not significant because 90% is easily accountable. But it could be that you start initially and you do not map the activities one-on-one and you end up with 90% indirect cost and 10% direct cost. Then you will not know what is happening in direct cost and you will not be able to have a better control over the cost. So, it's also dependent upon how granular you really want to go depending upon what kind of activities you are also doing. Okay. Basic story set, direct and indirect cost we are dealing with. Now, let me just give you an example of the kind of information needed for each of these things. Let's take an example of a direct cost and particularly on material. So, in material, what all factors could affect the cost, right? There is a direct requirement in terms of how much unit of material is required per activity or per unit of activity, right? So, you need to know the material required per unit. You need to also know how many units, how many activities or how much of activity will be done in a specific time. With that, you need to have some factor of how much material is required in per unit of that activity. For example, in a 1 meter cube of concreting, how much of aggregate you required versus how much of cement you required versus how much of sand you required. All these things you can do. different materials involved, you need to have an idea. You cannot be just going blind. Every activity has different type of material requirements. Proportions with respect to total volume. Sometime if you are dealing with cubic meter as a unit, then 10% of it is this, 10% of this, and 10 to 20% is this material. All that ratios you need to have. There's also a problem of wastage. Not all 100% efficiency in material usage is not there, because typically when you're preparing for some sort of a transformation requires concreting also. You mix raw material, then you add water, but then you are shifting it across so many different equipments. You can't remove the wastage 100%. There will be some concrete which will be stuck to that mixer and you cannot get it out easily, and so on and so forth, right? So there is always a wastage. There's something called a bulkage, which is essentially construction materials, their volume, final volume would be different than the sum of their individual constituent materials volume. For example, sand mixed with water expands a lot, right? So you need to consider, this becomes an important consideration when you have to deal with transferring of sand from one place to another, and that becomes your part of your costing, right? And you might be dealing with breakages, other kind of things. If you're dealing with glass, for example, it might break. Even after you have applied, sometime it might break. So that's again, you have to work around that. In terms of wastages, I think a good example would be the rebars, right? The rebars come with a pre-specified size from the manufacturer. So depending upon how your rebar schedule is able to accommodate, you might end up with so many small pieces, or you could have optimized your rebar calculation also, that you are having whole bars or longer bars compared to many small bars. Because small bars, you can never use them again. Longer bars as a additional material, you can even sell them back and you can use them to some other activities. So all of this is kind of information required. So immediately you can see just the material calculation can become so complicated because there are so many different detailing involved in it, right? So it's very important. The job is quite serious in a way that you need to have information from many sources, right? Just labor, if you want to estimate the resources, human resources requirement, of course you will have to estimate how many people of what type and all these things are needed. You also need to know what is the average output of these people in terms of how many units of work these people can do in a given unit of time. Now, depending upon whether they are skilled, unskilled, this number could change, or the kind of contribution they bring to a particular activity could change, right? Then there are labors of different type. There are labors involved in individual department who just needs there for checking approval or some sort of a supervision kind of a thing, sometimes just a guidance that okay, this is happening. You have plant operators and helpers which are taking care of a particular machinery, things like that. You have different type of masons, carpenters, fitters, helpers. Then you have subcontractors, laborers which are coming on your site. You could have a distinction between male and female laborers, because you might need to have different facilities prepared for them, and that will have a different cost implications. So you can imagine how messy it really becomes. There are so many variable factors on a construction site. So it's not a job of a single person to handle all this, right? Just giving you an idea. Again, in terms of plant and equipment, you need to identify what kind of machineries and what kind of equipment will be needed in order to complete the project in a given schedule. And you also need to understand how productive are these equipments, right? How many units of a work the equipment can do in a given number of hours or given kind of a thing. And therefore, you may need to understand the technical specifications sometime provided by the original manufacturer of equipment, right? When you buy a computer, you rely on the motherboard's speed and frequency and all this information you get. Sometimes you may need to do that, right? For a crane, how fast can the wire actually move in a second, in a minute? All these are specified by crane of the manufacturer in terms of what are the safe operating limits. Can you really move more faster, or can you make it really slow? All those things you need to know. What are the ranges? Otherwise, you'll not be able to estimate it properly. And then it's not, machine itself may not break as much, but then machine is clubbed with human. So the average efficiency of both of them needs to be taken into account. Human will require some break, even if you are working like a simple job, just pressing a button. You can't keep on pressing the button at 8 hours at the same efficiency level. But the machine only works when the button is pressed, even though machine's efficiency is not different. So a combination of them, you need to have a joint estimation of the efficiency, and many things. Like the whole idea is to give you that this is a slightly complicated topic when you actually have to do it. And typically you will see people working in finance department, over the years they accumulate so much interesting knowledge about the whole system because they have gone through so much of information exchange. They really understand what's happening, what's not happening, where things are, where things are not. So they become like knowledgeable a lot. So that's always there. This is just to give you an idea. Again, this is not directly related to our discussion topic, but in a typical bid is essentially the price that a vendor quotes or a subcontractor quotes, that I will do this work in this much amount, right? In a typical bid, of course, there is some profit of percentage margins and all, but it also involves a component of cost. If I have bidded for, let's say, 100 rupees, it could be that 20 rupees are my expectation of profit for the risks that I'm taking or whatever. 80 could be my actual cost. It's not like 100% of it is coming in my pocket, right? There is a cost to actually do that services. And this is the general structure that you follow in any civil engineering project. The direct cost, the labor, the equipment, crew which handles the specialized machinery, the materials, and any subcontractor cost. These are classified under direct heads. Then the project overhead, the common plant and equipment, and common workmen. Common workmen could be also there. Some specialized machinery, for example, or a project manager, let's say. He or she is overseeing everything. They are not attributed to any specific activity. So they are also considered in the overhead and sometime in the indirect cost. Okay, this is a general. You can always have, depending upon how granular information you have, you could attribute some to here and there. This is the generic structure we follow. Okay, any questions so far? Too much story, no numbers? Let me see if I can bring numbers. I'll bring soon. But I'll again still giving you a little bit more idea on what kind of details are needed in order to estimate these costs. So direct cost, when you're talking about cost of materials, see now, I'll give you an example. When you are buying material is not being produced at the site, maybe shop, right? Now one possible, and there is going to be a transportation cost, right? Now one possibility of accounting is that all transportation cost you will deal separately. So then you will identify individual transportation costs associated with each of these material each time it came, right? So then, or possibility is that you club this transportation into cost of the material that you're talking about. Maybe 1%, 2% of the material cost that is typically goes in the transportation, and therefore does not require any additional mention. It's just clubbed with the transportation cost, with the material cost, right? That depends upon what are you interested in. If as a company you are worried about your transportation cost, then maybe you need to do the exercise that individual transportation cost you are tracking very minutely. In that case, the material cost will be separate, the transportation cost of total material would be separate, transportation cost of machinery would be separate, and things like that you can still deal with. Or you club all these two individual of these activities so that they are still okay, not a problem. So it's not a 100% foolproof that this method will cover every possible type of cost. Depending upon your chosen reference or how detailed you want to track a particular cost, you could adopt something slightly differently, right? Theoretically, you should be able to attribute each transportation to each activity. But then if a labor takes Uber to come, which activity does it go to? Or a project management takes a car to come to site, and the fuel cost of that will go to where? Right? So all of this becomes messy. You can go as detailed, but then is it really worth it is the question, right? So this is a general, but it can change depending upon what you want to do. All right. So in general, cost of materials, there is actual cost of material. Sometimes you need to pay some taxes. That's so again, if as a company you are interested in how much tax I am paying, then you might tackle the tax separately. But on the other hand, you could do like, okay, lump sum cost of material is instead of 100 rupees, 110 rupees. That's the calculation I'll keep and I'll count as a complete as a material cost, right? See, in modern compute with uses of computer, you can actually do this easily because on a click of button, you can aggregate that same data differently and you will still get good estimates. But how does it go? Sometimes the billing itself does not have that minor level of details once it finally goes into a digital system. Therefore, it becomes a problem. Sometimes you can't even track all these things, right? Packaging of the material. If you need to pay, do you count it as a separate as a packaging cost or do you count it as a material cost kind of a thing? Freight charges, entry taxes, all these things are typically involved directly in the material price for per unit calculations. Okay. In labor, there is actual cost to employ the labor on site, but then which involves sometimes the basic wage, average wage, plus the bonus, right? Bonus you could track separately or you could keep it there. Welfare schemes, pensions, retrenchment, insurance, health benefits, social security, you could again track them separately or per unit labor, you could track to a specific activity, right? Cost of providing housing with or without arrangements of preparing food. All these are real issues. You need to deal with, you need to have a suitable facility for labor to live in because you don't want them to every morning travel from somewhere or sometime your schedules are working in the night. So they need to have a labor camp nearby where they can, and in that their families will also live and things like that. So these are all part of your cost of construction projects. And sometimes the mobilization and demobilization in a way that you need to bring, let's say 100 laborers from a particular place to here. Now they could say that how will we come? You need to arrange for a transportation vehicle, maybe a bus or whatever. So all this are in general attributed to a direct labor cost instead of tracking each of them separately so that your life becomes a little bit easier, right? So the main point that I'm trying to tell you is there can be even more detailed bifurcation and you could attribute some of this cost to an indirect cost theoretically, but is it worth is the question that you need to ask before you start doing that. Right, then cost of plant and equipment, it has many things. For example, of course, you have to either you are owning or you are leasing, so that's the cost you required. Mobilization, sometimes you bring a machine and then you need to assemble that on site, so you need to have a cost inbuilt on that. Operating, which you are paying for the laborers for that. Cost of fuel, oil, lubricants, all these machines require diesel and all some sort of a fuel source. Where's the cost of that going to happen? If repair is required, now you all in a construction, you will rarely find a repair or a maintenance head in the balance sheet or in any project activity because that is just clubbed into the equipment part. Okay, whatever 5% money we paid, it goes into the equipment side of it. Maintaining of spare parts, operators, drivers cost, any other demobilization cost and all. These are typically included lump sum under the plant and equipment and therefore it goes directly to a particular activity, right? And subcontractors is again a similar story. With me so far? All right. Indirect cost, again, just give you some ideas. Salaries, transportation, temporary installation, site accommodation, power connections, water facilities, sewage system, photographies, videos for progress update, travel and transfer cost, visits of headquarters, bade sahab aa rahe hain, all those things you need to accommodate in some sort of an indirect cost in a construction project, right? common plant and machine, common people who are safety related equipment, for example, safety nets, these keep on changing just the floor. Like you are just keep on bringing up. You can't attribute them to this is floor 1 safety equipment, kharcha itna, right? You can't do that. So typically that goes into common. Small tools and tackles, mobilization again, mess and food subsidies, entertainment purposes. You do, see, as a project manager, it's not only about getting the machinery done, and you ultimately leading people. And people function, all these things are basic necessity. You do need some sort of an entertainment, you do need some sort of a regular life outside the camp labor work or regular life outside the work, and you need to accommodate them, otherwise your projects will not function, right? So if you actually go on some big sites, you will see labor camp management itself becomes quite an interesting and challenging task, because machinery can function on remote or robotic or whatever your instructions are. People you need to deal with differently. And in general, project managers, good project managers always will have good people management skills as well, right? So that's a part of the job. And then there are certain times the indirect cost. This is more on terms of contract side of it, which is, I'm not going into too detail, but essentially there are a lot of money that you may need to give to the client as a guarantee that I will do a good job, and client want to secure their position. It basically risk transfer, like bid bond, performance bond, all these things, advance payment guarantee. So these you can attribute as a uniformly over the entire project. Okay. All right. So I'll just leave it here. You can go through these slides later. Again, just skipping one slide. Now, essentially, how do you do this? Right? That's the idea. So one basic way of dealing with this is, or a simplest way of defining is, you define something called a unit. You estimate all the charges for per unit, and then you simply multiply the number of units with that per unit cost to estimate the total cost, and similarly you keep on aggregating different type of units. That's the idea. Now, the definition of unit keeps on changing. That's the tricky part, because you cannot have one uniform way to define a unit. Concreting work you define through cubic meter, right? Usually it's a volume density. Wall, paint job, you usually define into meter square, which is the surface area, right? Brickwork, sometimes you define actually number of bricks, or you could actually define it the surface area also, again, because depth of the brick is remain same, so you can also define. So it's tricky, keeps on changing, right? So that's the idea, but the idea is you define the activities, you define a unit, you calculate the total number of units, you estimate the cost for each unit, and you aggregate to get the total cost that we have estimated, that we need to estimate, right? Now there are two ways of defining unit. Typically there is also the price, or how do you estimate the cost of individual unit. You actually rely on something called price book. This is also schedule of rates, often you will find. Typically these are government issued norms, that for labor, for skilled labor, this is the kind of average acceptable price, and this is available state by state, periodically gets updated every 5 years, 10 years. In India, you have reasonable number of estimates of what is happening. So you could rely on these numbers as a reference, or if you think no, it's a very specialized activity that does not fall into any of these predefined units, you could create your own unit and do the estimate for that, right? So that depends on your project requirement. But the typical idea is that you rely on pre-existing units as much as possible, estimate there, or you define yours and then do the work. Okay. Now there are two major ways, again just for the definition of it. In reality, you end up using both of them together. There is no clear way to distinguish them in a real project, but the idea is, one is called unit rate estimating, where your estimates the unit rate based on the summation of unit rates of all relevant elements, right? For example, 1 cubic meter of concrete is 10% of that is sand, or 20% of that is sand. So what is the 20% cost? 30% of it is cement, what is the water's volume or the money involved for 1 liter water, whatever. You combine and you say that, sir, this is the unit rate of concrete, 1 cubic meter of concrete, because so much material was required in that. Other thing is operational estimating, which essentially deals with some sort of a productivity norms. Sometimes what happens is, for example, if you want to estimate the labor charges for 1 cubic meter of concrete, how do you do? There is no per unit cubic meter labor charges like that. You have to have some estimate that how many laborers for how many hours would be required to achieve the 1 cubic meter of concrete, and then you balance them out. So this information, the productivity related information, is also essential. So this is called operational estimating, and typically you combine both of them in a measurement of anything, and I'll show you an example, okay, of all the things. But you got the idea, basic idea. One is just simply summation of the cost in a proportion. Other relies on the productivity related norms. But what we are saying is that in real, you need to do both. There's no one way about it. Alright, so let me give you an example of unit rate estimating. Do you know what OPC 43 is? Basically a grade of cement material. 1 metric ton is 1000 kg, right? So let's estimate how much is the cost of cement needed, right? So basic rate of material excluding cement, excluding cement factory price inclusive of all taxes, not excluding. It's basically cement factory price plus all taxes. This is the basic unit. For what is this? This is only for cement. This is not even for concrete, just for cement. Okay, you are not dealing with concrete. 1000 kg is the total you need to estimate it for. So unit is 1 metric ton, quantity is 1, the cost, you assume that right now you are going to know that these costs are still given to you, maybe some reference material, or you have collected all this information to gather here. So this comes out to be 5,700 rupees, right? Transportation to site, maybe a flat fee of 1000 rupees, 1000 rupees. Intercarting and handling at site. So typically you see people actually load and unload these cement bags maybe once from showroom or whatever that shop to the vehicle, and then finally from your vehicle to the place. In that also there could be multiple transportation, because one person will lift it and put in another bag person's head, that person will actually put it in somewhere where is the actual stock of material being handled. So it's given that on an average for each bag you need to handle it 4 times, and for each handling you are estimating 2 rupees per bag per handling, right? So 1000 kg, how many cement bags? How many? 20. One cement bag is 50 kg. So this is, again, you need to know this. Otherwise you can't do this calculation. You could have like 1 kg cement bag, then your cost of handling will become extremely difficult. If you are assuming 100 kg cement bag. So this is where the real knowledge also comes into the picture, that you cannot just be oblivious of these day-to-day conventions that are applicable in construction. But okay, 50 kg, standard cement size is this, cement bag size is this. So in 1000 kg, there are total 20 bags. Each bag requires 4 handlings, and each handling requires 2 rupees. So the total charge of just handling cost is 160 rupees, right? The total for this is 6,860. Some waste. On an average, you are assuming 2.5% waste. Again, this is where your margin gets built, because you are already taking factor of safety in everything. In civil engineering, we have very convenient way of doing things. If we can't estimate, we take a 1.2 margin, 1.3 margin, and everything will be settled in that. That's how the game of civil engineering is. So waste is 2.5%. So this is coming out to be around 170 rupees. This is a very interesting Indian concept, where the empty cement bag can be resold to whatever. There's a market for that. People will pay for this. So if you keep the bag in a reasonably good quality, and it has been opened from a very specific area, and you can easily reseal it and use it again. So it has a market. So that has 2 rupees per bag. So you actually get 20 into 2, 40 rupees back out of this. So how, see, I am estimating this also as part of my cost. So that later I don't have to worry, oh, what happened to those money when it was sold again, right? So the total cost is coming out to be about 6,992 rupees. And so per bag, it will be somewhere about 350 rupee per bag, right? So now, if you want to do the concreting work, and you know that in 1 cubic meter of concrete, how many cement bags you need, then you multiply the number of cement bags with this rupees to estimate only the cement component of 1 cubic meter concreting cost. Got the idea how we are doing it? Similarly, you can also have reinforcement. Let's say 1 metric ton of Fe415, which is the type of steel grade, essentially rebar of that. So this coming out to be some 35,750 rupees. Transportation of side, let's say it is already included. It is not additional information. Handling whatever this 300 rupees are given to you, you could estimate again how many rebars and all. Wastage is on 3%. Deduct for scrap, because again, all these material with small bars which you are finally reselling, maybe you are getting some money for that. So around 12,000 rupees. So this is coming out to be for 1000 kg steel, this is much you need to pay. Similarly, fine sand, basic cubic meter. Here the unit is cubic meter, right? Sand is a more of a bulk volume. Cement is also powder. You could have done it in cubic meter activity, but here the unit is bags. Here the unit is tons. Here is the unit is cubic meter. And this is how different units are. This is how cement industry is, or this is how in general construction business is, right? There's all sorts of units that you need to deal with. So basic cost at site in cubic meter, 1 cubic meter, 760 rupees. Some screening you need to do sometime. The sand is not pure. You need to like pass it through multiple sieves to get only the good content. Some wastage also happen, assuming 8%, because sand comes with a lot of impurities in it. It comes from many different sources, not as quality controlled as the cement bags, or not as certified as the your steel bar. But sand, don't know what is mixed in it sometimes. So let's say on an average that is wasted. So it comes out to be 82 rupees, 822 rupees. I'll just give you a brief example of labor, right? So one of the fundamental thing that you need to know in labor is the wages for skilled, unskilled and semi-skilled are different. So typically, of course, you can define mason versus bar bender versus blah blah, but on an average you could also classify them as skilled, unskilled or semi-skilled kind of a job. You could have a further distinction between skilled male versus skilled female. There are real differences on site. On paper you could say that there are not, but in real world, yes, women get paid less in most of the construction activities, and most of them are not even classified on the skilled side. They are generally kept to the unskilled type of labor jobs, right? That's the reality. So basic rate. In this basic rate, you are assuming 8 hours of time, right? It's also called, I'm forgetting the name, the Hindi name for this, Hajri. It's typically called Hajri. Hajri is like one presence. One presence mean 8 hours of work. That's like typical how you define the daily wage for people. So basic rate, you are saying that skilled is 673, semi-skilled 610 and unskilled is 536 rupees. This is not per hour. And this is not also per day. I am assuming that in a day they are working at 8 hours. That's the, again, you need to know this convention about the industry in order to get this. They also require some minor tools which they usually carry with them, and like for example a mason would have that plumb to check the level and all those things. They always carry, so you need to pay for that. Let's say 7.5%. If they do overtime, you need to pay for that. So I think here the assumption of overtime, if you do this calculation, is coming out to be 2 hours of overtime, and that money is about 25% extra of their basic rate or something. Or I think it's simply at the rate 25%, and then you are assuming that this is a 2 hours kind of. I have not checked the calculation, but essentially assume that 25% on an average they will do overwork and you need to pay them. So this is the money. The total is coming out to be this. Overhead, overhead and overtime are different. Overtime is additional work, overhead is extra cost that you are having on and above of whatever is this. So this is coming out to be this kind of a value. Now you need to have this is for skilled at different categories, but you also need to know in each unit of activity, on an average, what is the proportion, relative proportion of skilled versus semi-skilled versus unskilled. In 1 cubic meter of work, how many skilled versus how many unskilled versus how many semi-skilled you need in order to get an average number, right? So here that average number is 1 skilled worker for every 2 semi-skilled workers and every 4 unskilled workers. So that's the ratio, 1:2:4. So now you can take a weighted average of this particular wage so that you have a one number. Now you can multiply this number directly by the number of people required on that particular site, right? Or if you have individual estimate of how many skilled versus unskilled versus semi-skilled is needed, you can use the individual units, because this ratio may change from activity to activity. Concreting activity may be this, highly welding activity, maybe you need much more skilled compared to unskilled or semi-skilled, right? So this may also change. So hourly rate, considering 8 hours working time in a day, is about 109 rupees per hour. Why are you converting daily rate to an hourly? Because on a project you might work on 24 hours stay. So you need to have a really hourly estimate rather than the aggregated, where the assumption was implicit that only 8 hours of work happens in a day. So on an average you are able to find this number, 110, 109 rupees per hour. Okay, I'll stop here. We will take it from here.